name is Serge Borso, and I am a SANS certified instructor. I've been with SANS for about a decade, or over a decade, a little over a decade now. I taught classes way back in the day, like Sec 542, web app pen testing, ethical hacking, and here I am now teaching 488, which is our Cloud Security Essentials course, and I'm also the author for Sec 480, which is an AWS Secure Builder course. Outside of SANS, I've been in this industry for a little over 20 years now, and that's doing things anywhere from security awareness training in-house to system security to hardening endpoints to network security to application security, penetration testing, red teaming, purple teaming, and that's what I do now. Probably more than anything else, at least in terms of leading a team. And what I mean when I say that is, as the founder and CEO of SpiderSec, which is where I am, located here in Denver, Colorado, that's what we do: pen testing, offensive security, red teaming, and even some deep fake AI social engineering recently. A lot of fun stuff with that. Anyway, that's a little bit about me, a lot of certifications and degrees and whatnot. But with all of that, I usually stop about there to say, yeah, I got a lot of knowledge and I have a lot of experience, but you know what? I don't know everything. There is so much to learn and so much to know in the world of cybersecurity and cloud security and information security and computer science in general. It's a huge, huge amount of depth in this field and this topic, and I don't know everything. So keep that in mind. Not that this topic is going to get crazy in depth per se, talking about the shared responsibility model, but we can go to the level of depth that you would like to. The last thing I'll highlight is, in fact, check this out, our 10-year anniversary, 10 years of running my company, and I would say that's a pretty good definition of a success in terms of business. Very, very fun and great accomplishment, in my opinion. Here's our agenda. We're going to talk about let me back up a little bit. So what we're going to get into here is cloud security. When I say cloud security, I'm talking about, in the context of what we're going to be discussing today, honestly, more of the infrastructure as a service model, meaning that we're in GCP, we're in Azure, we're using AWS, one of those three big CSPs here in the United States. And as an organization that's using these CSPs, we are leveraging the full depth and breadth of the infrastructure that these service providers make available to us. Okay, a lot of words, and get used to it. I have a lot of words to say. But what that actually means is basically these are billion-dollar companies. They have huge data centers and lots of data centers that have redundancy. They have fiber optic networking. They have generators. They have millions of servers and hard drives and you name it, right? And we're leveraging all of that infrastructure to further our own business, right? So we have cloud-based workloads, and we have identity and access management, and we have machines that are running in our cloud environment. With that backdrop, what I want to talk about, and I'll tell you why in a moment because I think it's somewhat interesting. What I want to talk about now is basically us sharing the responsibility when it comes to securing that infrastructure. Now, the driver behind this was actually, I was working on, I don't know if white paper is the right word for it, but it was another SANS initiative with a couple of partner organizations where we're talking about like SecDevOps and basically security in the cloud, different facets to it, but that was the overarching topic. And I'm working on this document, and I submit it to get peer reviewed, and we submit it over to the ultimate customer to say, hey, does this look okay for you before we go to publish it? And they get some feedback. And when some of the feedback was that I kind of glossed over this whole shared responsibility model. I spent like, one or two sentences talking about it, and they're like, oh, there's more to it. And GCP actually calls it the shared fate model. And Azure actually does, stuff like that. So I kind of glossed over it there a little bit, and it sounds like the feedback that I received was, we should go a little more in depth with it. And I'm thinking, it's not really that complicated, right? But, as I challenge myself to take it upon myself to say, well, maybe I'm missing something here. Maybe there's more to it. That's kind of the impetus and driver behind this talk. All right. I'm checking out the chat. It's popping up here a little bit. I don't see anybody typing anything in per se, but I'll leave that there. All right, so that's our agenda. We're going to talk about things like this. Things do change in terms of who's responsible for what. Now, we'll start off with Amazon Web Services, AWS. This is the big CSP, which is our cloud service provider here in the United States. And what we're talking about, and I'll probably start off this way with this notion, if you will, and I'll probably end up with it as a conclusion because that's pretty much where I concluded when I'd researched all this. And that is, as we, you and I, as we deploy assets, services, machines, turn on IP addresses, turn on whatever it is, as we utilize cloud-based services, whatever we turn on, whatever we configure, we're ultimately responsible for securing. And I think another word here that would be apropos to this conversation is the word control. If we, as a cloud service customer, as a customer in the cloud, if we can control, quote unquote, it, if we can control the machine, if we can control the IAM account, if we can control the S3 bucket, if we can control the hard drive, if we can control the HSM, if we can control the whatever, we're responsible for securing it. If we can control it, we're responsible for securing it. There's a little bit of grayness here and there, but not a whole lot based on my knowledge and understanding. Okay, so within AWS, there is a split of shared responsibility. And each one of the CSPs, and we'll talk about each one of them, like I said, Azure, Google, and AWS here in their own little respective enclave, if you will. They all have their own take on, and documentation on here's what you're responsible for, here's what we're responsible for, here's a diagram to help convey it, and so on and so forth. What's somewhat interesting is the fact that it still takes effort to identify, well, what does that actually mean? Like reading through, okay, I'm responsible for sharing the responsibility with the cloud provider as pertains to ensuring there is a level of security being applied to my environment. So what does it actually mean? So I go, and the first thing is you and I would create an account. We have some type of identity and access management or federated identity in our cloud environment. And that's typically where everything starts from, identity. And with that identity, there is usually some two-factor authentication or some single sign-on or some password complexity requirements. And that's the first thing you're going to end up seeing. Like, how strong should my password be? Just as an example. And there's many, many examples, but that's probably just the first one that came to my mind. And what Amazon is going to say is, it's like, well, you're the one that's creating the account, you as in you and I, the customer, and therefore it's incumbent upon you and I to have a strong, complex password, something pretty basic like that. Now, if we neglect to do that, and then our account gets compromised, let's say we don't have two-factor authentication. Let's say we just have an account with a username and a password, and that account has admin rights, and the password isn't very strong, or the password has been reused and has been breached before, or there's malware on your endpoint, and the adversary then is able to obtain that password, and of course the username as well. They can then log into your account and gain access to your cloud infrastructure. Whose fault is that? Is that Amazon's fault? And maybe let's use a different word. Let's not use the word fault, perhaps, but that's the first thing that comes to my mind, quite frankly. Whose responsibility is that? Is it Amazon's responsibility to make your password complex? Is it Amazon's responsibility to not allow that login to be successful because they have some magic way of knowing it wasn't you? No. And that's really the impetus behind all this in terms of the shared model. And that's more of the focus on what we have control over and what we're responsible for. And of course, here in the slide, you can see the split and the customer focus component to this and different areas of responsibility. Here's what it graphically looks like in terms of AWS, where we can see there is a pretty clear, for the most part, delineation here between the customer, which is us in blue here at the top, and then AWS, our service provider. And the terminology, and this first came out well over a decade ago when Amazon gained more prominence and they started publishing things like this. And what they came out and said was responsibility for, or security in the cloud. This is what the customer is responsible for. Security, quote unquote, in the cloud. That's what you and I are responsible for. Amazon are responsible for security of the cloud. You're like, okay, yeah, I can read. What does that actually mean? What that actually means is, think of the word infrastructure once again. And that's going to be the things I said before, the generators, the fiber optic networking cables, the redundancy, all of the physical components inside of those data centers across all the world. That's Amazon's responsibility to keep it up, to keep it running, and to keep it secured to some extent. Right now, that's the gray area. Like, what do I mean some extent? What am I talking about? Well, from an availability, and let's back up a little bit, and throughout, since a lot of us here might be CISSPs, and this is, drilled into our heads whenever you did the CISSP training, confidentiality, integrity, availability. Those are the three things us as security professionals are generally going to be on the hook for lack of better words. Okay. Confidentiality, integrity, availability. Now, availability being the letter A in the CIA triad, right? We're talking about keeping things up and running. Availability, uptime. That's what we're referring to. And that's where we say Amazon's responsible for security, quote unquote, of the cloud. So making sure the data centers are working for, there's more to it than quote unquote working, but making sure those data centers are hosting our services and maintaining uptime and available, basically is what it comes down to. But beyond that, physical security. You and I have zero control over the physical security of those Amazon data centers. And therefore, that's not our responsibility. We're not going to like physically go to the data center and jump over the fence and then, try to break into the door and say, "Hey, Amazon, your fence wasn't high enough and you're missing a camera over there. And this door I was able to, pick the lock." That's not how it works, generally speaking, unless you have a really fun contract to do a physical pen test with Amazon, but that's perhaps neither here nor there. The point is that down here we're seeing things like the regions of where these data centers are located at, the availability zones, also things like the hypervisor when we're using infrastructure as service, because this is a public cloud environment and there is a sense of shared hardware that's abstracted by the hypervisor, and that's something you and I are not going to have access to. That's something that our CSP, cloud service provider, has to then maintain the integrity and security of. And of course, on top of this, you can see what we're responsible for, which is without going into, the process of reading things you can read for yourself. We're talking about as you start deploying services on top of the AWS infrastructure, what you deploy, what you turn on, what you use, what you get charged money for, you and I are responsible for securing. Now I'll pause for a moment and ask if there's any questions so far or any other comments or chats that anybody wants to talk about before I move on to talk about Azure. And you don't need to wait for me to pause. You are more than welcome, of course, to send a message at any moment in time you choose to. With that being said, let's move on to Azure. And within Azure, what we're talking about is the same thing, same topic, the shared responsibility model. The way that I've found over the course of doing some research on this, that Azure breaks this down in terms of, once again, who's responsible for what. The terminology varies a bit, as does the impetus, where Azure or Microsoft as an organization says, you, the customer, really need to focus your efforts on these things. And this is going to be customer responsibility, data, devices, identities. Identity is probably the main, based on my research, the main area where Azure says and points you into saying, this is the area where you want to focus most of your attention, which is true of any cloud computing environment. And when I say that, what I mean is treating identity as the perimeter, the security perimeter, as in everything starts with identity. If an adversary, going back to the example I gave before, is able to compromise your account, the attacker now is you for all intents and purposes. So if you can't secure the identity of your users, then we have a huge problem. And that's typically where Azure steps in and says, from a shared responsibility model, this is where you want to focus your efforts. Now, the sharing piece here, of course, it says customer, what's shared, and what's the provider responsibility. So they break it down a little bit. It's a little bit different than what Azure did a moment ago, or sorry, what AWS did just a moment ago. They're saying it depends on what model you're using. And what I've been talking about so far as a backdrop has been infrastructure as a service, IaaS. But as you can see, there's also platform as a service, there's functions as a service, there's software as a service, there's a bunch of other, identity as a service, database as a service, you name it. There's a lot of other as a services that exist. But these are the three big ones right here: identity, platform, and software as a service. So depending on what it is that you're using, the model shifts a little bit, but ideally, or not ideally, but in reality, at the end of the day, it still comes down to, based on my experience here, whatever it is that you control, you have responsibility for securing. And let's give a quick example here of what that would look like with software as a service. So when I say software as a service, and let's stick with the Microsoft example for this. So the main software as a service platform that I can think of that comes to mind first for Microsoft is going to be Microsoft 365, right? Huge platform service software offering for Microsoft. And that's where a lot of us have our productivity services, our Outlook, our PowerPoints, our cloud-based services, hence software as a service. You pay money, you have access to these services, and they're all in the cloud. All right, cool. As pertains to the shared responsibility model with software as a service, where do you draw the line of delineation between who's responsible for what? And the answer in this case is going to be, well, we have a lot less control with Microsoft 365 if we compare that to what level of control we have with using Azure. As in AWS and in Azure, using infrastructure as a service, I can deploy virtual machines, and I can deploy storage accounts, and I can deploy containers, and I can use Kubernetes, and I can turn on all these wonderful features and services, and that's great. But with software as a service, that's not how it goes. It's like, oh, I logged into Microsoft 365, and now I'm using Outlook in my browser. What am I possibly going to be responsible for securing as pertains to this? You and I didn't write the code that is supporting what we're using in the browser with Outlook, right? It's not like we wrote the source code. We have no control over the source code. We have no control over that website being online and running. We have no control over anything other than basically logging into the account, which goes back to, once again, identity and access management, IAM, and also things like what is it that we're choosing to share with other users inside of Outlook? Using EIP, thinking about DLP solutions, or even our Drive, our OneDrive, our Google Drive, our cloud-based storage. So things like that. Now we're talking about data classification, and we're talking about lifecycle management. How long are we going to allow these certain files to exist beyond their needed use? We delete things automatically after 1 year or whatever it is. And that's what we're talking more about. We still are responsible for securing this component of this service offering because, once again, we have control over it. Like when we log in and when we choose to share documents. And that's where, do we want to buy a data leakage or data loss prevention service? Do we want to pay money for so on and so forth? Then, of course, we have the last thing here, which is the provider responsibility. And this is going to be for physical and some other platform level controls. And this is, generally speaking, what it looks like when Azure tries to break it down. What you're seeing here is what Microsoft Azure is responsible for, what us, the customer, is responsible for in these dark blue squares. And then shared would be, half dark blue and half probably azul. That's probably what that color might be, or turquoise. Anyway, the other component here is, who's responsible. And if it varies a little bit, or if it's just the cloud provider itself. And also, as you can clearly see, it's broken down. It, as in the responsibility model, is clearly broken down by our category: software as a service, platform as a service, infrastructure as a service, and even on-prem hosting something yourself. This is not uncommon. Amazon has a very similar, diagram. Google, if you looked for it, probably have something very similar as well. The point that's trying to be conveyed here, once again, is that there's many different facets to what you're using in the cloud. And that goes back to, quote unquote, the responsibility column right here: information, what you're responsible for, down to the operating system, and even the physical data centers, right? There you have it. Then we have GCP. Terminology-wise, this is where it gets interesting because we're not calling it the shared responsibility model. It's the exact same thing, in my opinion, but it's just called the shared fate model. Does that matter? I don't know. If you're being quizzed on it, it might matter, but I don't think it matters too much. The idea here is exactly the same we've already talked about. And the reason I'm highlighting this, even though it's pretty much the same, is because there are some slight variations, and because maybe you're using Google and you're like, oh, cool, we're talking about GCP. What's the difference here? Shared fate, as in if something goes wrong, we're both going to pay the price for it. right? And you got to think of this, you don't have to think of it this way, but I have a tendency to think of it this way every now and then. And that is you and I were using a cloud provider. And some of us, depending where we work at, we're talking like millions of dollars a month worth of a bill that we're getting from Amazon or from GCP or Azure because we're using a lot of their services. That's not uncommon. Like that's a thing. I've worked with customers on a regular basis that spend a large, relatively large quantity of money every single month in their cloud service provider of choice. Now, I mention that because I think it's relevant because of what I'm about to say, and that is the fact that if there is an outage, if there is a breach, if and when something bad happens, and you and I are relying upon our service provider for some component of security, it it's a bad day for both of us. It's pretty much what it comes down to. If we get breached, one of the first things it's like, oh, was it? Well, maybe not one of the first things, but it's human nature, I think, to ask questions about the root cause. How did this breach occur? Was it our service provider? Did Okta get compromised? Did GCP get compromised? Was it our service? Was it our third party vendor? Was it whatever? Or was it us? Did we make a mistake? And honestly, here we are, in the current, state of the world we live in right now, and it's not just us by ourselves. Like we have a provider, we have third party vendors, we have this supply chain that we rely upon for the security of our infrastructure. And because of all that, it's very difficult to say sometimes, immediately what the exact root cause of the problem was. Now, I mention all this because of the shared fate model, meaning that if there's an issue with our provider or an issue with us that ends up resulting in a ransomware attack or successful compromise or something along those lines, the provider themselves, they typically take that very seriously. I can tell you with a high level of confidence that none of these CSPs we're talking about, Google, Azure, or AWS, want to see anything bad happen to their customers, right? That's bad for business. Kind of goes without saying, but it's also a truism, and I think it's worth mentioning because these providers do put a lot of effort and money into securing their platform, and then offering us, the customer, the ability to leverage some of those security controls and tools and services to further enhance our own security posture. So when we have a misconfiguration in our CSP that results in a compromise or some type of data breach, it's shared fate in that if you as a customer are choosing not to use these services that we are making available to you, we as in GCP in this example, then we're both going to pay the price for this. You're going to maybe have less confidence in our platform, or you're not going to want to be associated with our platform anymore, or even if it's like, you and I misconfigured the service and that's why we got breached. You could go back and say, well, how come, the provider didn't do something more? How come whatever it is? And that's, once again, I think human nature. So I'll leave it at that. And of course, you can read the slides here for yourself. I'm not much for reading words from slides myself. That's what it's there for you. And here we have a nice graphical representation of what GCP has for their shared fate model. It should look pretty similar to AWS and to Azure. All right, cool. I'll leave that at that. And I'll move into the next thing here, which are some examples. And this should be a little bit of fun. All right, so let's switch things up a little bit. EC2 examples. This is our AWS example. EC2 is basically a virtual machine inside of AWS. And what we're going to do is talk through this. All right, so let's check this out. AWS, Amazon Web Services, they manage our virtual machines and physical hosts on the network and the network itself. So what we then do as a customer is we choose to turn on an EC2 instance. And as part of this process, we get to choose if we want Microsoft Windows, or if we want Red Hat Enterprise Linux, or if we want, whatever flavor of operating system that we generally choose. That's you and I, we choose that. But it's running it as in the operating system that we choose to turn on is running on top of their physical hosts and their physical infrastructure. Okay, there is in this case AWS. Now, what happens next is time elapses, and at some point we need to think about patching the operating system. Now, also, I'll pause for a moment to highlight the fact that what we're referring to here is an example of infrastructure as a service, as in from a responsibility perspective, I'm not going to click a bunch of buttons to go all the way back to the AWS example so you can see graphically, but I will remind you that when we're talking about host-based patching and application patching, that's 100% our responsibility. And this actually came up from, I think, some student interactions earlier this year where I was teaching a class and one of the students asked, does the cloud provider patch our machines for us? And the answer was no, definitely not. And if you think about it, some of us are like, well, of course not. Some of us are thinking, well, why wouldn't the CSP? Like, aren't we paying money for that? The answer is no. When we're using infrastructure as a service, we're choosing to deploy this operating system. We're choosing the operating system itself. We're choosing how big it is, like how much RAM, what CPU, how big the hard drive is. We're installing an operating system on there. We're also configuring networking, like do we want to allow SSH or RDP or web-based services? We're choosing all those things, and then we're clicking a button or using infrastructure as code to turn on this machine in this example. And then at that point, we have a real live functioning web app or EC2 instance or whatever the VM is designed to do. Okay. Now, with that being said, you think back to who is going to now patch this thing? Well, it's you and I. We turn it on, we control it, we maintain it. And if we neglect to do so, that's on us. It's our responsibility. And think of it in the opposite kind of example there. What if the CSP was responsible for patching that machine? Think about it for a second. Think of, in my opinion, for lack of better words, the absolute nightmare that would be to have a third party, maybe second party, depending on how you define first, second, third parties, but having your cloud provider actually have access to your machine that you turned on, you built, you configured, and they're just gonna like patch it. Like, how would they do that? They log in, they have access, they have some access. How do they apply those patches? And they have to reboot the machine. Is it gonna cause downtime? Is the CSP going to then coordinate with you and I to figure out when the appropriate maintenance window is to reboot this machine? What happens if it doesn't come back online? They cause an outage. What happens if we're talking about PCI DSS for credit card processing? And this is a extremely sensitive environment. And now we have our cloud provider that has some level of access to our machines. We have to be concerned to some level, a big level, that they're going to then have access to all this PII, and in this case, PCI data. All right. And that would be not at all some risk that any company would want to take on. Generally speaking, when we have our own colo or our data center, that's because we want to have the utmost security and control over our environment. When we're talking about using shared provider and infrastructure as a service, we really would not want to have anyone else have access to our infrastructure because of the example I just gave of highly sensitive information potentially being accessed, which is a loss of confidentiality, or rebooting a machine, or interacting with the machine in a way that causes outage. Once again, it's loss of availability, confidentiality, availability, or of course, modification to a database that modifies the integrity of our data. So those would all be critical security failures. That's basically how it would play out. So to wrap up this example, the CSP in the example of infrastructure as a service has zero control over our EC2 instance, other than, of course, the underlying infrastructure being online and running. They were not going to log in. They're not going to patch the machine for us. They're not going to tell us, oh, you have some malware on your endpoint, unless we maybe pay for another service that does something similar, like using AWS Security Hub. Here's another example of how potential maliciousness could cause harm to us. Here we have, or just a regular user accessing a machine, either one of these. We have an end user uses SSH, the SSH into our EC2 instance. All right, pretty common for any Linux-based operating system and any means of remotely administering a Linux-based machine. All right, so what's the problem with this? There's no problem. It's an example. An example here is, how is this SSH connection actually working? And the answer is there's a firewall. We call security groups inside of AWS, and we have security groups associated with this EC2 instance, which essentially allows us to add a firewall rule in place right here and this delineator in the AWS cloud infrastructure to allow this SSH access through and then into our EC2 instance. that is once again an example of something you and I are 100% responsible for. Okay, so if we choose to allow other ports or services through other than SSH port 22, maybe we're allowing port 80, port 443, port 3389, port 21, whatever it is, it's incumbent upon us to understand the inherent risk that then brings to the table. Okay, let's move on to the next example. This is logging, using, once again, infrastructure as a service. And here we have the example of AWS CloudTrail. So once again, we're in AWS, and we're using CloudTrail to automatically log API calls and any account activity. This service by default is going to track, who, what, when, where, why, those type of things, and exactly from within our AWS account and accounts in general for API calls and for IAM activity. AWS at this point is responsible for the infrastructure that captures and stores these logs. What does that mean? It means there's a default service, generally speaking, it's called CloudTrail inside of AWS. As you and I and other people on our team, at our business, at our organization where we work for, when we log in to AWS, that's an API call. When we click a button inside of AWS, that's an API call. When we turn on a machine, when we change the name of something, when we deploy VPC, those are all API calls that are intrinsically linked to IAM, Identity and Access Management, as in it was your account or my account that clicked on this link that performed this action, okay? And all those actions go to CloudTrail, where there's a record of what has been occurring in the environment linked to users, okay? This is the backdrop. And once again, the third bullet point here, AWS is responsible for the infrastructure that captures and stores these logs, as in CloudTrail is a service. It's a service that Amazon has written code to create. Then they turn around and sell to us, basically, depending on what we have configured. We then have the responsibility to analyze and act upon these logs. What does that mean? It means, yeah, Amazon has some default logging. Cool. How much value is that? Well, you tell me. Are you looking at those logs? Is anybody on your team looking at those logs? Do you have a SIM? Do you have some way of automating the process of parsing those logs to identify malicious or suspicious activity? Because that's on you. The first half, Amazon does it. The second half of, are we doing anything with this information at our fingertips? And the answer is no. And all of a sudden, you're in your logs, there's anomalous activity, there's brute force attacks, there's compromised credentials that are pretty obvious when you look back at the logs, and you and I weren't paying attention to that. Kind of goes back to whose fault is that? And more importantly, and to my point I'm making this whole presentation is, it's a shared responsibility model. Like the tools and services are there for us to use. It's just incumbent upon us to choose to use them. And it's like wielding a tool. Like, yeah, I have a welder. I don't know how to use the welder, but I have a welder. It's like, go weld something. Go learn how to use the tool properly. You have a wrench. Do you know how to use a wrench? You have CloudTrail. Are you looking at the logs? That's what we're talking about. Here's an example of what this might actually look like. Where we have beyond just CloudTrail, we have many different things going on here. What I want to convey with this is the fact that it's not just the topic of built-in tools and services inside of our CSPs that we're using. It's also the idea of leveraging these tools in such a way that we're conforming to or adhering to industry best practices and security best practices outlined by our CSP or via CIS benchmarks, for example. All right, there are, generally speaking, very clear directions on how to configure a key management service or CloudTrail. And I'll just pause right there and give a quick example. Like with CloudTrail, you have 90 days worth of default logs inside of AWS and inside of Azure for that matter. After 90 days, the logs roll over and you still have 90 days. But if you've been in business for a couple of years and something happened, 8 months ago, and you only have 3 months worth of logs, right? Like, once again, the tools are there. It's incumbent upon us to configure and use those properly. Okay. All right, those are two infrastructure as service examples, like having a virtual machine, an EC2 instance with SSH open perhaps, as well as cloud-based logging, where we can clearly see the tools exist, but it's up to us to use CloudTrail in that case appropriately. Let's talk about platform as a service. With platform as a service, this is where it's a little bit different. When I say platform as a service, we're talking about we're maybe a developer or something along those lines, and we want to run our website, but we don't want to have to deal with all the underlying annoyance, for lack of better words, of patching a machine and having redundancy and having encryption at rest and having it can't maybe the CSP can do all that stuff for us. And when we get to that point of our conversation, that's what we want, we end up selecting something like platform as a service where we have Elastic Beanstalk or Azure App Services. And from there, we're now telling or having the cloud service provider handle the underlying patching of the operating system for us. Okay. So with platform as a service, the CSP manages the operating system. However, vulnerabilities in customer and custom written application code are still, once again, our responsibility. So what does that actually mean? It means, yes, using Elastic Beanstalk in AWS means that AWS will ensure to some extent, the security and stability of the underlying operating system and the platform on which our application is going to run. Cool. What happens if we write code poorly? Like, yeah, you're speaking my language now. We all write code. We all do it kind of poorly, unless it's like our day job. All right, in that situation, the poorly written code that has maybe security vulnerabilities because we wrote code poorly or we relied upon some vibe coding and didn't really pan out the way we thought it was going to. However, we get to that point, we end up having the situation where, once again, we have a published, running, live, if you will, web application with vulnerabilities. Not vulnerabilities in the operating system, not vulnerabilities in the platform itself per se, but vulnerabilities in the source code. So we have a SQL injection vulnerability or cross-site scripting vulnerability or other things on our top 10 list from OWASP. That is an example of something that would be our responsibility. Now, here's where it gets a little more interesting. The cloud service provider, they have a library, as in their platform as a service offering is leveraging some type of Java-based library or PHP or something with inside of the software build materials, and it has a vulnerability. And the question is it their responsibility to patch that? And it kind of depends. Like, well, where's that library? Is it a library that they provided to us? Are we using it? Do we have an ability to not use it? Like, can we work around that library? Is it something? And here's where I'll go back to the theme from before. Is this something that we directly control? And here's where it gets a little more interesting, though, like a database connection library. Like, in order for us to use RDS with the Elastic Beanstalk, there's a database connector library that is the default status quo. Everyone who uses Elastic Beanstalk and RDS leverages this connector library. That's what we all do, but it's not our code, and it's not quite something we have full control over without breaking the functionality of the application. Whose job is it to fix that? So a little bit more of a interesting type of question at that point. Now, as you can see from this pretty interesting diagram, there are a number of other services that may come into the conversation where we need to be thinking like this. I said the software bill of materials a moment before, that's the SBOM. Understanding all the libraries, all the software that comprise our applications that we're running inside of our organization becomes a rather challenging process. And for you to understand, once again, who's responsible for fixing those vulnerabilities that crop up in each one of those services, it's going to be something that you want to maybe go into to understand the risks. All right, let's move on to a software as a service example. And I guess before I do, I'll just remind everyone that you're free to ask questions in the chat if you have any. All right, so for this example, we have a software as a service provider, and they're securing the platform, and we're securing the data within the platform that we're using. The example I actually gave before was Microsoft 365, and I mentioned that it's our responsibility to focus on the identity and access management. In this case, it would be having password complexity in place, having a single sign-on, federated identity, multi-factor authentication, whatever that looks like for your organization today, as long as it's set up properly and works well, which that's a bit vague and open to interpretation. I got a lot of software as a service services that I'm using, and they all work. How well they work? They work pretty well. How convenient are they to use? Yeah, that's a different different topic for different time. All right, so our responsibility includes, like I said, this component. Managing user access is also going to be something that we're responsible for, as well as data loss or data leakage, that type of prevention. Because of the fact that we're neglecting to do that, we have some really serious issues. I see a question from Joseph. Do you see service level agreements, SLAs, SLA tiers of support increasing in the future for the cloud services, especially in small businesses? All right, another example here, like I said, DLP, that's on you. And even with secure platform, of course, if you choose to or end up using it insecurely, you're going to have an issue at the end of the day. Sorry I didn't have a better answer for you, but like I said, I'll think about some more. Whether or not I'll answer it better, that remains to be seen. But all right, here's the example of exactly what I was talking about, the whole multi-factor authentication thing. I'm not going to go into any depth with this. It's just keeping in mind that this is our responsibility. If you neglect to have 2FA or MFA, as the case may be, you're going to put yourself, generally speaking, in a pretty weak position. But this is something that takes effort to configure, takes something like buy-in also from leadership, generally at some level, to ensure you have the right solution, whether that's a YubiKey, some type of FIDO, or whether this is going to be push notification, or whether it's going to be however you choose to implement it. There are stronger and better ways, but honestly, to this day, I don't see this changing either. You kind of have security or you kind of have convenience. And once you start kind of shifting that, your security goes up, your convenience goes down, and vice versa. So maybe at some point that will change, but usually the stronger, better your solution is, the less convenient it happens to be. I don't know, that might change at some point. What else has changed? What's changed over the years? All right, so a lot of things. Documentation probably being the one big one. The whole idea here that our cloud providers make it, in my opinion, pretty clear. If you choose to read through the documentation, you can pretty much see like this is what's expected of you as a customer. When I say that, what I refer to is as you're using infrastructure or software platform as a service, there are, generally speaking, detailed documentation that each one of our CSPs make available to us, so we don't really have to guess, like, what am I supposed to do? What am I responsible for? There's also benchmarks. I alluded to CIS benchmarks. There's also best practices that are forms of written documentation directly from Azure and GCP, as well as AWS. Like the providers themselves are telling you this is what you need to do to leverage this service in a secure fashion. So it generally takes the guesswork out of it. Should you or your team actually go through the process of reading that documentation and then applying it? Okay. Other than that, yeah, tooling. Tooling would probably be the main other thing. And this is kind of going hand in hand with the world we live in, where things constantly, in my opinion, get better from a technology perspective, right? Sometimes there's regressions, like, yeah, I'll leave it at that. But generally speaking, things get way better. And the tools that exist, whether we're talking about like Sentinel, or we're talking about Security Hub, or we're talking about Defender for Cloud, or even the command centers at GCP and things like that, we have a lot of flexibility with some awesome tools that already exist to help with this process. So what's the point? What is the use of those tools? What to look forward to? Automation. Okay, automation, quote unquote, maybe AI. When I say quote unquote AI, it's like at some point in time that will probably definitely get way more mature than it is right now. And actually, I'm sure a lot of us are probably getting a lot of value out of what exists today from a free or paid perspective. But I think in 5 years or less, probably it's going to be way, way, way better. So keep an eye out for that, as if you could avoid it if you wanted to. But probably some incorporation of AI tooling. Now, what would that actually look like? I can only speculate. I don't know if it's worth speculating on it, but there's going to be probably tighter integration of what this agent knows about your environment and what the output is and what the automation of fixes actually looks like. When I say automation of fixes, I'm talking about we deploy a service, we misconfigure a service, and now there's a way to fix it. Or we go back to the drawing board and say, before we even deployed the service, we've done so in a secure fashion. So all the best practices from the vendor have already been taken into account. And when we go to deploy, we're pretty highly confident that we're doing so in a secure fashion with maybe some trade-offs between. So that's pretty much what I see: tools and the integration of probably more advanced AI agents or AI technology in general. And that's going to be more than likely on the horizon. What probably won't change is the fact that it's going to be incumbent upon us as humans to choose to use some of these services, and except for maybe five or 10 year pipeline where things are going to be forced, um, like just integrated or built in. And one example that we're seeing right now would actually be going back to the conversation about multi-factor authentication, right? Where our service providers are well aware of the importance of having two-factor authentication in place, because that does a very good job when implemented properly to reduce the likelihood of getting breached. They have chosen to say, you don't have a choice anymore. If you want to use this platform, if you want to use AWS or you want to use Azure for your business, you are going to have 2FA turned on, period. And I'm seeing that slowly change over time, as opposed to 5 years ago. Say, if you want it, it's there. Now it's, or even 10 years ago, if you want it, it's going to cost you money. Not with CSPs specifically, but other examples where it's like, if first you're going to charge you for it, then we're going to make it free, then we're going to make it easy, and then we're going to make it mandatory, right? And that's one example of the shift, and that could be tooling going forward as well. Thomas says, currently for automation and AI, it appears like GCP is ahead of AWS and Azure. That's a question mark after that. I can speak to, of course, my experience, and also I was at RSA. I was also just at the Rocky Mountain Information Security Conference here in Denver, Colorado last week. So I'm saying that to convey that I'm speaking to other peers and leaders in the community and people who are speaking on these topics to try to stay abreast of this ever-changing landscape, quite frankly. Like I said at the beginning, I know a lot, but I don't know everything. So in the context of all of that, Thomas, GCP, I've gotten more value out of GCP's AI Gemini tool, and I've gotten a lot of, how do I say this politely and professionally? I haven't gotten a lot of value out of like Amazon Q, for example, Copilot, and these are like the public-facing free AI services, the generative AI services that each one of these CSPs has in some capacity or another. Those are the ones I've used. I don't have any behind the scenes or anything special. So I'm sure some of you have probably gone above and beyond some of the stuff that I've done with each one of those examples: Amazon Q and GCP, having Gemini built in, and then Azure with Copilot. GCP probably, in my opinion, actually would be one of the more robust options out there, the Gemini option. But that's today. Ask me again in a month, and it may vary. The other thing I'll say on that topic, Thomas, and everyone else is wondering, what the most value you can get out of, quote unquote AI integration in the CSP would be: go out there and test it, play around with it if you can. Okay, I understand that there's some hurdles to entry, some barriers to entry, if you will, where you have to have a credit card or an account, or your company has to give you some type of sandbox area to check out some of these tools. But I would almost go as far as saying you might be doing yourself a disservice if you're not staying on top of these AI tools today, especially as pertains to not just the shared responsibility model, but security of the cloud in general, right? And that's the bigger impetus and part of the conversation here, of course. That's it. That's all I have. I want to thank you for your time. I sincerely hope you got some value out of this. And I'll also draw your attention, and Joseph, this may be even especially for you. We can pick up the conversation about the outsourcing of IT and SLAs. Hit me up on LinkedIn. I like to think I do a pretty good job of responding to people who do reach out, and even with thoughtful responses every now and then. But with that, once again, my name is Serge Borso. I want to say thank you so much. If you have any other questions, now's a pretty good time to ask those questions. I see one more thing here. You're very welcome, Joseph. And for everyone else here, once again, hopefully you got a lot of value out of it. I'll leave it at that. Thank you so much for your time. Enjoy the rest of your day, and thank you.